Welcome to Braille Institute. You can visit the www.brailleinstitute.com Actuarial Statistics, that is a CS1 160 classes available. You can register with your email ID. Registration option is there with your email ID. So type your email ID and register it. There is a verification. After verification you can register. Then log in with your email ID with your password. Then payment options available, different payment options, that means in chapter wise, module wise, and full modules. Then 160 classes available, 160 classes and questions and answers, mock test available in our this all you can purchase with your login. So now here we are studying the base theorem. So we already studied this base theorem. Base theorem is explaining about the conditional probabilities. So what is the conditional probability? We already studied in the chapter 4. Conditional probability is A given B. So A given B is equal to probability of A intersection B divided by probability of B. So that is the probability of A given B. So what is the conditional probability? We can take with some example. I have a roll a die. I have a die, I am rolling the die. So my A event is the even number. A event I am writing even number. So what are the even numbers? 2, 4, 6. And B event is greater than 3, greater than and equal to 3. So face number is getting greater than or equal to 3. So that is my B event. So what are the possibilities are there? 3, 4, 5, 6. There are the many possibilities are there. So here I have a single event, and I have a single event. I have a die. That die I am throwing. If I am getting 4 will be in the both places there. If I am getting 6 also in the both places are there. And if I am getting 1 is not there in the universe. So I am just typing. My universe is rolling the die. So my universe is I am just typing rolling the die. So this is my universe. And what are the samples is there? 1, 2, 3, 4, 5, 6. What are the options is there? So I am rolling the die. There is a chances of 1, 2, 3, 4, 5, 6. This all chances is there. But my A event is the A event only 2, 4, 6. There is a chance of 2, 4, 6. And B event is greater than 3, number greater than 3. That we are considering the B event. So what are the chances are there in B event? This is a event. B are the 4, 3, 5. So these are the chances. But in 4 and 6 in between, A and B both have the 4 and 6 options. So probability is getting 4. There is a event it is there and 6 event. So that one we can call the A intersection B. That if you are getting A intersection B, we can type the what is the probability. So here is a probability of A given B. A given B. Probability of first initially this is a probability of A intersection B divided by probability of B. So first we are taking the probability of A intersection B. So here I am just writing the probability of A intersection B. What is the probability of A intersection B? We have a total 6. Here it is a 2 chances are for the A intersection B. So we can write the 2 divided by 6. So this is equal to the 1 divided by 3. So 1 divided by 3, there is a chance of 1 divided by 3. If you are getting 4 will come in the A and B. If you are throwing the die, if you are getting the 6, face is 6 will be in the both cases. 6 will be, we can include in the A event and also we can write the B event also. So there is a intersection B, it is a 2 by 6, is 1 by 6, 1 by 3. And next is the probability of B. What are the probability of B? What are the total probability of B? Total probability of B is a 1, 2, 3, 4. So 4 divided by 6. If you are throwing the die, if you get any one number, what are the chance of any number have the 1 by 6 probability? So 1 is getting 1 by 6, 2 is getting 1 by 6, 3 is getting 1 by 6, another is, all the probabilities are 1 by 6. So probability of B is equal to 4 numbers are there, 4 by 6. probability of A, what is the probability of A? It's a 3 numbers, you can write the 3 by 6. So these are the probabilities. Now you can substitute here probability of A intersection B, that is equal to 1 by 3 divided by probability of B. So this is this you can write the 2 by 3. Here I write the 1 by 3. So here it is a probability of B, that is a 2 by 3. So this we can equal to the 3 is 3, 1 by 2. So this is a 1 by 2. So this is the probability of A intersection B. A given B, A there is a condition B, under B, A there is a condition of under B, our equation is A intersection B. That we can directly we can take the A under condition of B. Under condition, what are the terms are there? 3, 4, 5, 6. Under this condition, what is the chance of A? 4 and 6, there is a chance of, so 2 by 4, so that is equal to the 1 by 2. So you see under the B condition, so here it is under B, B under the B given by B, so B is the total probability in here A given B, and A is equal to 4, 6. So what are the probability of getting A? 4 and 6. There is a 4 and 6 only here. So we can write the 2 by 4 is equal to the 1 by 2. And also we can write A, B given A. So probability of B given A, we can write probability of B intersection A whole divided by probability of A. B intersection A whole divided by probability of A. So B intersection A. So what is the probability of B intersection A? This is a 1 by 2, not a 1 by 3. This is a 1 by 2. 3 by 6 is equal to 1 by 2. So what is the B intersection A? B intersection A is equal to, so here we know that A probability of A intersection B equal to the probability of B intersection A. So both are equal. Now see, probability of A intersection B, B intersection, both are equal. So we can write here also it is a 1 by 3. B intersection A also equal to the A intersection B. So that is 1 by 3. Probability of A. Probability of A is a 3. 2, 4, 6. That's a 3 divided by 6 is there. So 1 by 2. So here it is a 1 divided by 2. So this is equal to the 2 by 3. So what is the probability? 2 by 3. Now we understood that the probability of A given B not equal to probability of B given A. It is not equal. Probability of A given B not equal to probability of B given A. Now probability of B given A, in a Bayes theorem, probability of B given A will write in terms of the probability of A given B. So probability of A given B, how to write? This is a 1 by 2. We can write the probability of A given B from the equation of the probability of A given B. We can write instead of A intersection B. So we have a formula for the here you see probability of B given A in terms of probability of A given B. So probability of B given A, here probability of B intersection A. So this one we can substitute here. Here we can write like that. Probability of A intersection B. A intersection B, we can write the probability of A given B and probability of A. Probability of B, not A. Probability of B. So now you see this term is taken here. Probability of A intersection B, we can write probability of A given B and probability of B. So this multiplying these two, we can write here. Now you see instead of B intersection A, I am substituting here probability of A given B and probability of B. So this is given by probability of A. So this is the formula for the Bayes theorem. This is the basic of the formula for the Bayes theorem. Probability of B whole divided by probability of A. So this is the basic of Bayes theorem. So here it is the probability of B given A, probability of B intersection A divided by probability of A. B intersection A equal to the A intersection B. Both are same, 4 and 6. So we can substitute B intersection A. Here A intersection A and B intersection A are equal. So we substitute this value, probability A given B and probability of B, multiplying with the probability of B. So that you can call the probability divided by probability A, you can call the, this is the Bayes theorem. This is the Bayes theorem. So this is a single event. Single event, I understood that how to get the Bayes theorem. We have a one roll the die, 2 forces, 3 5 forces, two types of event. We find out the probability A given B, and probability A given B. We understood that probability A intersection B and probability of B. This probability A intersection B equivalent or B given A. So we can substitute, instead of probability A intersection B, we can substitute A given B divided by multiply with the probability of B. So both substituted here, so we got the equation of the Bayes theorem. Now we consider the many cases. So this is it's a concept we will use for the many cases. So for example, instead of rolling a die, here we have only one event. Now we are considering the many event. So our universe is writing in a big bracket. This is a universe. That means a total probability. All the probabilities will be here. So one event A is happening. That event I am just typing like that. This is the event A. This is event A. This is, you can write U. This universe, this total probability, I am dividing to 3 portions. We can divide number of portions. I am just dividing to 3 portions. So this is, I am dividing like that. This is 1 and 3. Now you see, I divided this total probability, this total probability I divided to 3. So this we can call the B1, this we can call the B2, and this is divided the B3. So my universe is in my total sample space. So my total population, or we can write the here it's a population. So I have a population. Total population, I have a total population, this one. So we have a number of events in the population. I am taking this all cases. I am considering this all cases by taking the samples. I am taking the samples of all the cases. In sample, I am dividing this one is each portion. I am taking all the samples, many samples. So you can write the B1, B2. Here I am taking the 3 only. So I have only 3 cases. So this universe, this is all the population, all the chance of probabilities. I divide into the 3 portion, B1, B2, B3. And this A event, you see what is the particularity of A event? A event is happening in the B1 also. So here is a portion. This portion I can write, that portion I can write A intersection B. A intersection B, or B1 intersection A. You can write like that. B1 intersection A. So this portion is a B1 intersection A. This B2, we can write the B2 intersection A. Here you can write B3 intersection A. Now you see, A is the event everywhere. All the cases, all the probability cases, all the event. This is a one sample space. This is another sample. This is all event is happening. So here will be a event will be there. This is A not event. A event will happen from the B1. A event will happen from the B2. A naught. Dash is representing A naught. And here also, this sample also, A event is happening, A naught is happening. So this all is happening here. This A event is total for this probability. So we divide into some portion. So B1, B2, B3. So how to write this formula for the Bayes theorem? So Bayes theorem formula is equal to probability of B given A is equal to the probability of A given B, probability of B divided by probability of A. So what is the chance of probability of A? You see, what is the chance of probability of A? Probability of A, here it is a B3 intersection A. So what are the chances? Here is a probability of B1 intersection A plus probability of B2 intersection A and plus probability of B3 intersection A. So these are the all probabilities there for happening in the A. These are the 3 probabilities are there. Here plus, here plus, here plus. So this probability of A we can write probability of this all possibilities, that we can write probability of A intersection B1, probability of B1. Probability of A intersection B1, probability of B1 plus this we can write A intersection B1 also. We can write like that, A intersection B1 or B intersection A1, whatever may be. This is happening probability of this A intersection B1 or B intersection A, whatever may be, we can write both way. So both are equal. Both are equal. So this one, this probability, what is the chance under B1, given the B1, what is the chance of A, and the probability of total probability of B1. Here is a B2 intersection A. So this we can write like that, the probability of A given B2 and the probability of B2 whole divided, not whole divided by. So this is a chance of B to A. So probability of here is studied, probability of A given B, we can write like that. Probability of A given B, A intersection B, we can write probability of A given B and probability of B. So this way we can write this whole. Now you see probability of total probability, here also we can write B3 intersection A. So this also probability of A given B3 and a probability of B3. So total probability of A is represented like that. So here in the Bayes theorem, what is the total probability of A? Total probability of A is representing total plus this all is representing the total probability. So probability of A is equal to this all. If we are dividing more, it will be here. So plus another is up to, it will be. So that is the total probability. So probability of A is representing the total probability. And probability A given B, probability of B, this one is representing single event, single portion. That if we are asking about the B2, for example, what is the probability of happening from the B2? So what we can write, a probability of A given B2 and probability of B2 whole divided by total probability. So total probability is this like that. So this is the formula for the Bayes theorem. So individually we are taking one probability, and this is a total probability. That is a meaning, A given B, probability of B divided by total probability. This is a total probability. So individually you can take a one probability divided by total probability. So this universe is divided, I divide only B2. You can divide another way, another B4. If you are dividing here, it will be a B4. We can take some example, we will understand this concept. In a manufacturing company, so three suppliers are there. In a manufacturing company, three suppliers are there, B1, B2, B3. So these are the three suppliers. These suppliers, what are the chances? B1 is supplying 60%. So B1 chance is 60% is supplying by the B1. So 60% is supplying by the B1. So in a company, total is representing as a total. 60% is supplying by the B1. And B2 company is supplying the 30%. 30% is supplying by the B2. And B3 company is another 10% is supplying by the B3. So what are the probability of B1 is 60%, here is a 30%, here it is a 10%. So here we can, B1 is a big, so here we can write B2, here we can write the 30%, just writing here B1 60% and B3 is 1. Just term is changed because here it is a big one, so easy to, some confusion will come. So just B1 I am taken this portion, B2 is this portion and B3 is this portion. So B1 is, this B1 manufacturing company is supplying the 60%, B2 is supplying 30%. B1 intersection A, B2 intersection. So what is the event of A? Event A is the event, it is a event is saying that something faulty material, supplying the faulty items. Event A is the faulty items. Faulty items, what are the chances are there in faulty items? Faulty items chance is 10% from the B1. Here it is a chance of 10%. 10% from the B1 and 5% from the B2. Here it is a chance of 5%. You can write, we can write in red. So here there is a chance of 10% from the B1 and 5% from the B2 and 15% from the B3. So this is a condition. B1 is supplying. So what are the probability? Here it is 0.6 B1 and here it is 0.3. Probability 30% means 0.3. B3 is a 10% means 0.1. So faulty, A is an event of fault. Faulty items is supplying. A is an event of faulty items 10% from the B1. So here it is A is an event. A is an event, we can write 0.1%. So what is A not? So 0.9% is not faulty items. It's a good items. B2 is a event. B2 is a event. 30% there is a chance of from the B2. B2 is supplying 30% of the company's all the products, and there is a 5% there is chance 0.05. So not a faulty item 0.95. And B3 is supplying only 10% and 15% 0.15% is a faulty item, 0.85% is not a faulty item. Now we are asking about what is the faulty item supplying by the B2. They are asking about the event in the garment faulty items from the B2. What are the faulty items from the B3? Now the first question is asking about what is the faulty items from the B3. So B3, what is the faulty items from the B3? We have to change the formula from the B3 in faulty items A. So here it is a B3, here it is a B3. So our formula is become probability of B3. A is a faulty items coming from the manufacturing company B3. So A is the total probability is happening. This portion is asking about B3. So this portion asking about this portion, you can write this portion. So what is the probability of getting this portion? This portion, what is the probability of getting this portion? So is company supplying getting faulty items, that what is the probability of getting from the B3? So now you see in the base theorem I changed B3 given A. Under the event of faulty item, what are the chance of getting from the B3? What are the chance of getting from the B3? So here I written faulty items under B3. What is the chance of getting B3 and how much B3 is supplying divided by total probability of faulty items. So now what is the equation? Probability of A B3 and probability of B3. So what is this one? Probability of A B3. A, here is a probability of B3. What is the probability of B3? That is a 0.1. Selecting the total probability. In total in the company we are supplying only 10%. So we can write the 0.1, this one. Probability of B3 we can write the 0.1. What is A given B3? Under B3 what are the faulty items? 0.15. So A given B3 it is a 0.15. Here it is written 15% means 0.15. 15% means 0.15. So this is supplying from the B3. B3 selection of B3 is 10%, 0.1, and total probability from the B3 is only 10%. Out of 10%, 15% are faulty. Out of 10%, 15% are faulty. So same way probability of A is a total event. What is a total event? Total event we can write here. Probability of A given B1. B1 is what is the probability of selecting the B1 is 0.6. And A from the B1, what are the chances there? 0.1. 0.1 is A. So this is A. This is A event. So what is the chance? 0.1. And plus probability of A given B2. Probability of A from the B2. B2 is 0.05. Multiplying with the probability of B2, total probability. So this is 0.3 plus A given B3. B3 is 0.15. Multiplying with the what is the probability of selecting the B3 is 0.1. So this is the total probability. So this total probability will get the 0.09. So it will get 0.09. So here 0.09. So this will get 0.167. So this is the total probability. So now you see selecting the B3. So what are first initially what is the selecting the B3? First we given the selecting the B3. what is selecting the B3? So 10 percentage. So B3 is selection itself only 10 percentage. Out of 10, 15 percentage fault. So out of 10, 15 percentage is fault. So we have to multiply 0.1 with 0.15 and divide by total probability. Total probability is considering all the default items, all the faulty items, supplying by the all companies, B1, B2, B3, any other companies. So that we multiplied here. From the B1 company, what is the chance? And B2 company, how much is giving? B3 company, what are the faulty items is giving? So that is a total probability is 0.09. So out of 0.09, 0.015 is the here. So we got the answer. And what is it from the B2? B2 also we can write like that. From the B2, what will be the from the B2? So here very easily we can write it. From the B2, what is the probability? Probability of B2. B2 given A, we can write the same way. From the probability of B2, here it is a 0.05 multiplied with 0.3 whole divided by 0.09 total probability. One probability divided by total probability. You can try. What is the probability of B1? So probability of B1 given A. So that you can take from this total probability 0.01, 0.1 multiplied with 0.6 divided by total probability 0.09. So in under here, this is probability of A is representing the what are the chance of event faulty items or event faulty items is a total probability for the total probability. So here is representing individual probability. Here it is representing total probability. Hope we understood about the concept of Bayes theorem, how to write the formula and how to divide in. This is a tree diagram. We can write the tree diagram. So how to draw the tree diagram, and from the tree diagram easily will understand it. B1 what is the probability? 0.6. B2 what is the probability? 0.3. B3 what is the probability? 0.1. So from the tree diagram we can easily will write the total probability. B1 is selected, and out of B1 what is the chance of faulty item? 0.1. Out of B2 0.3. What is the faulty item? So easily we can write the total probability. First if you return the total probability, what is asked? What they are asked? B3 given A. So what is the chance of B3 divided by total probability? What is the chance of B2 divided by total probability? What is B1 given A means what is the chance of B1 divided by total probability? So easily we can solve the problem. So this is the Bayes theorem. So concept is understood. The concept. Next class we will study about the more than what is the concept of Bayes theorem. That is a prior and posterior distribution. Thank you.